quantum computing. So what exactly is quantum computing? Well, let's take a look at classical computing first in order to find out. Classical computers operate under what's known as a bit, operating sets of instructions through a sequence of ones and zeros. This is done through transistors, switches which controls the flow of electric current through it. When turned on, allows electric current to pass, thus outputting a signal of 1 and hence a signal of 0 when the switch is off. Instead of bits, quantum computing uses a qubit. As mentioned earlier, classical computers has either one of two states in which it can occupy. However, qubits can occupy both these states at the same time. This is known as quantum superposition. Okay, so I've explained the difference between a qubit and a bit, but what exactly are the advantages of a qubit? Let's have a look at a 2-bit computer. There are 4 possible states of which a 2-bit computer can compute, 1 state per operation, whereas a 2-qubit computer, due to its quantum behavior, is able to analyze all 4 of these states at the same time, as 2-qubit contains information about all 4 of these states. The number of computations quantum computing can do is 2 to the power of n being the number of qubits present. Consequently, quantum computers are able to solve problems that are currently out of reach from the classical computers we use today. However, this assumes quantum computers adopt a type of algorithm different to classical computers in order to exploit this quantum phenomenon. So how exactly do we build a quantum computer? Well, we need to find a suitable material to use that exhibits this superposition behavior. These exist at a nanoscopic level. The problem with this though is that once these materials start to interact with its environment, i.e. on the macroscopic level, in this case interaction with other qubits, and when we actually measure the state in which this particular particle is in, then this superposition behavior collapses. This is known as quantum decoherence. Due to this, the technology today is insufficient to commercially manufacture quantum computers for the mass, and therefore you won't see a quantum computer sitting on your desk anytime soon. However, a company called D-Wave has supposedly manufactured a series of quantum computers, although it hasn't been 100% confirmed whether this is actually one, or just a classical computer simulating quantum computer-like properties. So, to conclude, will quantum computers ever replace classical ones? Well, there are no considerable advantages to quantum computing when it comes to uses such as writing up a document or browsing the web. In fact, some tests shows that quantum computers may even be slower at these sorts of computations. Despite this, quantum computers do have considerable advantages at solving certain complicated problems like encryption, and therefore I believe in the future, when quantum computers can be easily mass-produced, it will be specialized much like the GPU, working side by side with classical processors in a hybrid-like system.